Hello, engineers. Welcome to SystemDesign.us YouTube channel, where we conduct distributed system design mock interviews. Our interviewers are senior FANG engineers, and we also have a course at SystemDesign.us. Please listen the entire interview and visit SystemDesign.us for feedback to understand what went right and wrong. We also suggest actionable solutions to get better at designing systems. And don't forget to subscribe to our YouTube channel and click that bell icon so that you do not miss any new interviews.
Yeah, I'm actually looking to practice interviewing myself. So I've actually never done a system design interview, so I'm definitely trying to get a good, I guess, feel for it.
Okay. How much have you been working in the industry for a long time, or how much
Yeah, about 4 years now. Just like as a
okay.
backend developer. So
Okay.
yeah, but I've never really had to work with like distributed systems before. So I've just been reading, and you can study all you want, but obviously you
Yeah.
have to put in the practice to
Yeah.
get
For sure. For sure. And
master.
so you're looking to switch roles into distributed systems, or
I mean, at least definitely work on like more scalable systems, because like I haven't really worked on anything that needed to scale a whole ton. So,
okay,
I'm trying to develop a better like instinct essentially.
makes sense.
Okay, design an app store system.
Yeah. So I posted my question there. So please go to that question and think about it. Think about how you would propose a solution, and take your time, and then we can discuss what you come up with.
Got it. Sounds good. But yeah, let's I guess just talk about this a bit, and maybe
Yeah.
try and come up with the like a high level approach. So,
Yep.
um, okay, so I'm thinking, obviously something like Google Play or Apple Store.
That's right.
Developers can publish their apps and users can download them.
Yep.
Okay, and so when developers publish an app needs to go through a verification process. Once approved, it will be available for users to download. Okay, apps can be free or paid and have in-app purchases. Okay, these transactions should go through the App Store system. Okay. Okay, and they'll pay out the developers for the payments made by users of their app. Okay. Okay, so just from a high level, just to, I guess, sort of scope out the features.
Yeah.
Obviously,
Yep.
we have a central store in which apps will first of all have the ability to be, I guess, like ingested into our system by developers. There's some sort
Yes.
of verification process. Can I ask you, like, what I guess is involved in that verification process? Is it something like automated or something like
So I think for
that
this
has to?
this problem, you can assume that it's pretty much a black box, and you can assume that it's a verification service that you don't need to
Okay,
get into details of how actually the verification will happen. I'm more interested in, like you said, in a distributed system design where how the system will look from end to end, and not details.
got it,
Yeah.
got it.
Although I would like you to go into the scale and how you would handle, the data flow, and where you would see the bottlenecks and things like that. Not
Got
individual
it.
features like how the verification will happen.
I see what you're saying. Yeah, let's definitely start high level. I still can't drag and drop anything, but that's okay. Hopefully it'll catch up. Okay, so yeah, I think like the feature set makes sense. So let's talk a bit about, okay, well, just to clarify, right? The bare like minimum of this whole system as far as features go, we need a place to ingest and download apps. So that's, I would say that's, kind of like a feature in and of itself.
Yes.
And then, like you said, the verification system, but that's more of like a black box. We just have to incorporate it somewhere. And then payments, that's probably going to be a big one.
Yes.
Either to pay for like the app itself, like I'm assuming like on the download? Well, I guess it'd be like, yeah, okay. So we'll discuss that more in detail.
Yeah.
But those are the three core features. Um,
Sure.
so I think that's pretty straightforward. Um, so maybe let's start with talking about the APIs of the system, and how, you know, external people will access it. Let me see if I can get a text box here. Here we go. Okay. Let me know if you
Are
can
you
see the
right?
text.
Yeah, I can see that. But are you writing the APIs? I
Not
mean,
yet.
okay, because
Yeah, yeah.
I'm thinking like APIs are not really that useful in this case, right? Because we're not really designing like a API, like a developer API that we're exposing to external users. So I'm not really interested in API design. I'm kind of more interested in the overall end-to-end design, from how it looks from, let's say users go into their phones or some other device and search for apps, and then, or that's like one side of the marketplace, and the other side is developers go into their computers, submit apps, and how does that look from a backend distributed point of view?
Okay. Can I ask you, I guess, like, I'm trying to get an idea of how much data we're going to be handling and like the capacity of the system. How many, I guess, users are we expecting on average, right? So I guess there's really two main like subsets of you. There's the developers, the publishers, and then there's the actual users downloading apps. So do we have an idea of
we
how
can
many users
assume
we're supporting?
about a million developers and maybe, let's say, 1 billion users.
Okay. And is that like on a monthly basis or?
Yeah, we can assume a monthly basis.
Okay. Okay, and so each, I guess, application itself, as far as like storage goes, I guess, trying to get an idea of how much storage we need on average, right? Do you think maybe like, I don't know, like 100 megabytes would be
Yeah,
accurate?
100 megabytes for an average app would be a good estimate.
Okay. Okay, so what else? So we have 1 billion users
Also,
we're trying to
as a
support.
general question, do you think these metrics matter? This is not related specifically to this question, but do you think these metrics matter, like 1 million developers and 1 billion users for designing a final system?
They matter in a sense of just like how much we need to scale, but I think I do see what you're getting at, right? Because ideally we'd want to design this in a way where it doesn't really matter how many users we have, because we want to be able to just scale it, you know, linearly,
Right,
horizontally. So
right.
yeah. Okay, so did you want me to, I guess, kind of just not focus on the estimates and jump into the component design?
Yes, yes.
Okay. Okay, so let's see. I think I'd probably, okay, let's start with like the upload of an application by developers.
Yeah.
So
Yeah, that's
maybe
a good
let's talk,
first use case to start with.
got it, okay. So let's think about what that actually looks like. A developer creates some application and they want to ingest it into our system. Um, I'm assuming that would just be like a binary, right? I
Sure.
mean, I guess yeah. I guess we could support like other formats, but let's just start there, like for the
Yeah,
simple case. So
yeah.
we have all of these, you know, binary files, you know, about 100 megabytes, like we talked about, and
Mm-hmm.
we need to store them obviously in a way that I would think where they can be, you know, easily accessed and downloaded efficiently by users from pretty much anywhere.
Sure.
So the first thing that comes to mind would be to use something like object storage, something like an S3,
Okay.
just because, you know, that's exactly what it's designed for. It's highly available, and from what I know, like I've used S3, it shouldn't be too difficult hook it up
Yeah.
to like a CDN, for example, and distribute that data. So
Yeah.
that's what I'm thinking as far as storage. So let's say we
Sure.
have, oh, get rid of this, sorry. Okay. So let me try to just map this out with like the simple case before
Yeah.
worrying about like lots and lots of servers. And
Yeah.
okay, so we have S3,
Mhm.
and this is where applications are stored. Okay. And so obviously each application is going to have, like a unique object ID. We need a way to, associate those with different users in our accounts. And that sort of brings me to my next point. We're going to need some sort of like user system or
Mhm.
user service, where any developer can, or company, can create their own account within our system where all of their apps are. So yep. So let's say we have user service. Now this service obviously will be taking requests from our from a client somewhere.
Mhm.
Oh, I keep grabbing this. Okay. And so the S3 is just for the storage of the applications itself, but we also need to store, like I said, the user data, which is going to be in our user service. So as far as like a database goes, I guess we could go MySQL or NoSQL. Let's talk about like, did you want me to go into like the schema and like the data itself? I
Not the
think,
schema, but I would like you to uh, make that decision on why you would use MySQL versus NoSQL and pick one.
yeah. So I think just as far as like the user data goes, it's pretty straightforward. I don't see it like changing too much, although it could.
Yeah.
So I guess we
Mhm.
could go with MySQL.
So
That'd probably
if the
be,
data changes, you're saying you would use MySQL?
no, I'm saying it doesn't seem like it would change that much, like user metadata. Like it seems like pretty structured data, right? As far as the schema goes. So in that
Right.
case, MySQL would be, a pretty good option. If it
Yeah.
does change, and we're doing different, associations with, we're combining user data and, we're doing different queries with other data throughout our system, then we might want to go like no SQL to keep like a flexible schema.
Okay.
Also like if we're doing joins with user data and say like some other data set, we probably want to go MySQL because it's not really,
Right.
something that's a good idea with NoSQL. So I guess just to start, I'd go with like a MySQL or like a Postgres or something to store user data. And so
Makes
we would
sense.
have, that would be part of this user service. Let's just put this here. User data. Okay. So yeah, like I said, let's talk about what this sort of ingest process looks like. A client makes a, once they're authenticated, assuming, let's say we have, a load balancer to distribute our load in front of this, that knows our service. And, let's say we just have a cluster of machines in our user service, right? A client is going to make a request to our user service to publish an application. Now, personally, I think it's somewhat of like an expensive operation just because we're uploading, say, like 100 megabytes to our system per user.
Right.
you know, a million times a month.
Sure.
So I would try to do this process asynchronously.
Okay.
And you know, we can just let the client know, like, hey, we're working on your upload, and you know, you could check back in later on that.
Okay.
So what would that look like? In order to do that, right? Um, I guess there's a couple different ways we could do it. One way might be to, you know, when we accept the client request, we can create like a job where we're going to process their data. Maybe we have like distributed worker nodes that can just work on one particular thing, which is just uploading um, those binaries to S3. That's one way I'm thinking
Within
of
the
doing
job, you're saying within the job
it.
or within the
Right.
user service.
So the user service is really, to me, just for handling user requests and like associating their applications with or associating like their user accounts with like what apps that they own, right?
Okay.
Um, yeah. So a client sends a request to the user service. The user service takes that request, and I'm thinking the user service itself can generate, say, like a job, right, and send like a job ID back to the client, and it sends it, you know, to some external component. And let's say, like, I'm thinking maybe a decent way to handle this would be to have some sort of like distributed, like cluster of like worker nodes that each take requests from the user service and process them and upload them to S3. So
Like a separate distributed service, essentially.
exactly, like a separate microservice, essentially.
Right. Right.
So right. So let's just call this app, you know, ingest service. Okay, and so this, I have an arrow. Oh, okay. And so the user service, it's going to send the user ID, obviously, along with, say, I would have like the app ingest service generate like a new job ID and send that back.
Okay. Sure.
Yeah. And then like the binary itself, yeah, so that, like when they actually upload the binary, say through our, you know, desktop app or mobile client or whatever, that, like, I'm wondering if that should go through, like be passed through the user service
You mean
to
the
our app
actual
ingest
binary?
service. Yeah, you actually, you know what I'm thinking? I'm thinking maybe like the client, right? So the client makes a request, they submit this request into our system, but when they actually upload their binary, maybe it just gets uploaded directly to our app ingest service.
Which one
Because
do you
I'm
think
thinking,
would be better?
if they
Ultimately,
upload,
it's all about efficiency in terms of time, processing, and space, right? Or memory rather. So you can think along those terms. Which path always gives you, you know, the most optimal configuration in terms of, you know, the most efficient use of time,
yeah,
server resources.
yeah,
Yeah.
so if the focus is on efficiency, like, you know, assuming everything is behind like a load balancer, we can authenticate, I'd have the client send a request directly to our app ingest service, say using like the user ID and like the job ID, where
Right.
the app ingest service can just, pick up that job ID and work on processing it.
Right,
Um,
right.
and,
Because
and
once
so,
once the user service is authenticated or whatever it needs to do as an initial setup, it doesn't need to keep interacting with the client, right? If it is not the one and saving that binary itself. So then it's just an extra
exactly,
hop that you're introducing in the network.
exactly, right. Yeah, and I was just thinking, like, how do we set up that request between like our client and our ingest service, right? So
Right.
the client would send, a user ID and a job ID, as like parameters in
Sure.
the API. Now, what happens next when the user service creates that, say, like scheduled job in our app ingest service?
Mhm.
Nothing happens right off the bat, but this is, and we're obviously going to need to store that. We can store that in some type of data storage, right? Where this app ingest service has, where it's basically just pulling like scheduled jobs from the database to process them. And that happens when the client asks or makes that request to ingest. So the ingest service gets a job ID, it pulls that, say, like from the database. But then again, like, let me think about this for a second. What sort of data do we need to store here? So assuming like they're authenticated and we have a job ID, and we have a binary that's coming in this request, we may be able to just start processing this just directly, without needing to like read from a database. I mean, maybe we could use a database to store like, like metrics, like maybe like the
Mhm.
status of the job, whether it's failed or,
Sure.
you know,
Yeah.
but I think just as far as like the bare minimum operation, we don't really need to store everything because we already have the binary and, the user ID. And so we
Right.
can just have this start processing. You know what I
Right.
mean?
Yeah.
So yeah, the storage would be more so for, like debugging and metrics later down the line.
Sure.
But maybe I can just ignore that for now. What do you think?
Yeah. I think that makes sense.
Okay. So once that happens, like I said, we're going to upload our application, our binary file to S3. And then how do we know that, say like object belongs to our user? We can just basically take the object ID and store it in a table with the user ID.
Right.
And so to me, that would, like, who would own that data, right? Either probably the user service. Yeah. So in that case, we would send that, say, like request to our user service. If that
Mhm.
API is like, complete a job or process job, we'd send
Right.
over the, user ID with an object ID from
Makes
S3,
sense.
and that would be stored in our user metadata.
Makes sense.
Okay. And then once that whole process completes, assuming the client, would we need to notify the client like in real time when that completes? Or is that just something like that they could check back in on, or?
Yeah, it might be best to notify.
Yeah. Okay. So in that case, so like as soon as the application is like finished publishing, right, and it's on the App Store, so to speak, we want to send them, say, like a notification.
Sure.
Okay. So in that case, I'm thinking we may need a separate service, like a notification service,
Okay.
that can essentially just take, any random notification and distribute it out to like clients directly, right? So let me,
But there's only one client to be notified, right?
yeah, right. I'm just talking like the notification service as a whole, like, if it's just this black box, it can take any type of notification, and then it
Okay.
should know like which one belongs to which client. And that's like the
Mhm.
job of the notification service. So
Sure.
let me, can I like zoom out? I need a little bit more space. Let me see.
I think there's a plus or minus sign on the bottom
Yep.
right, right?
Okay, got it. Okay, so I think we covered like the ingest process so far, right? So let's just talk
Mhm.
about that notification service. So all of this itself, okay, so we so far have two really microservices. And so this is our system as a whole. Let's add one more. Okay. And so this notification service can take requests from any part of the system. And so what it would be storing, we're going to need a couple of things. Excuse me. And so this will be like the notification DB. Say like a notification type, ingest, completed, download, all different
Sure.
types of notifications
Makes
that are
sense.
associated with user IDs
Mhm.
and maybe like a message and like, maybe like some other metadata, right? So
Yeah.
this is essentially a database of messages.
Mhm.
Okay, I was gonna sort of think about like the database itself, but let me come back to that really quick just to sort of flesh out how this
Yeah.
would flow.
Yeah.
So, okay, so we have a client. How do we send this message to the client? So when I
I think
think of,
I
sorry?
think it makes sense. It makes sense. This notification service and that flow makes sense. But in the interest of time, should we work on how the users will download the app and that part of the design?
Yeah, yeah, definitely, definitely. Okay, so yeah, I can come back to this. Okay, so right, let's talk about how users download an application. So, okay, so that sort of brings me to another point, right? Users need to be able to go through, some sort of, store and see what they can download. And so one thing I forgot when on the ingest is like, we need a place to store all the different data pertaining to the app. Like it's all of its metadata, its title, description, how many
Right.
users downloaded it, so far and so forth.
Right.
So that's the first thing we're going to
Mhm.
need to add to the solution that we have so far, because we're going to need to store that so that we can later, query from that in a nice way. So let's say app metadata service. And so this
Mhm.
service is responsible for storing all that data and just handling, reads and writes. And it's going to have its own database. And so on the ingest, let's assume that our, say, like user service can send a request to the app metadata service with all the data that the client provides, and we can efficiently store that. So
Sure.
assuming we have this, implemented, and we can come back to how this would work, but assuming we
Mhm.
have this,
Mhm.
so now we have more clients, and these are people who are going to download.
Right.
And so they are going to browse our store. You know, in a very simple case, let's assume maybe so it depends, I guess, how they're going to query, right? Like in,
Right.
we could do it in like a paginated fashion, or maybe develop some sort of, like feed with like suggestions.
Right.
Um,
How would they discover the app is what you're
it,
getting at.
exactly. Right. Right. Um, well, I guess, what do you think is just as far as like user experience? Should we just sort of model it
I
after,
think
like,
I think for this design, you can probably, because the scope of this design is so large, for this problem is so large, you can assume that it's probably a search box that they can search in.
I'm sorry,
Yeah,
could you say that last part?
we can assume that there is a search box in the operating system that they can search in. We don't need to design a feed, because that's a whole different problem
Right,
altogether. Yeah.
right, right. Okay. So yeah, let's just assume that they have to search for apps they want to download. Okay.
Yeah.
So the client then would send a request to like our app metadata service. And I don't think we'd have any really like authentication or permissions to worry about. But yeah, they're going to send, say, like a search term, right? Spotify.
Mhm.
What I'm thinking is, maybe we could have, say, like an Elasticsearch that could handle that for like the
Sure.
search component, you know,
Right.
to do like a full text search. So we could have that storage component behind our like metadata service.
Mhm.
But then we could also maybe have like another more um, persistent storage solution, um,
Mhm.
where we store everything, obviously. But just
Right.
just to handle this simple case of a search, right? Let's say they get a hit from Elasticsearch, they get back, that object for, Spotify, um, app ID, so on and so forth.
Yeah.
What would that look like? Maybe we have this service send back like a unique like download link where the
Mhm.
clients can download this directly. And so then that brings me to, we would just have like a download service for users.
Which will live in the client, or
No, so I'm thinking that the client here,
okay, okay. I see what you mean.
yeah, let me try and draw this. Yeah, all right, I might be getting some lag, but yeah, I'm thinking we have this app metadata service. Oh, there we go. Send back, the structured object of whatever application it is. Say like Spotify has an app ID, but it also contains, say, like an app download link that's generated by our system. That
Mhm.
link is what the client is going to use to download the actual binary itself onto their system directly. And what
Mhm.
I'm thinking would handle that is just like a download service. That's the endpoint for that link.
Right.
Okay, all right, I'm still getting some lag. Okay, so let's talk about that. What is this service going to do? It's going to take client requests for downloads specifically. Um, but I think I kind of mentioned earlier, right? When we have these binaries in S3,
Mhm.
um, we can either have like our download service pull these from S3 and just send them back directly to the client, or we could set up, like a CDN solution where we could have the um, where we could actually just have the client, directly pull from a CDN and have the
Mhm.
link, directly to that object and a CDN.
Okay.
I think that would be the better solution, just because we can, distribute the data geographically, so that we reduce, latency and it's closer to the client. Because these are big downloads, it's not like small, bits of JSON. So I think that's
So
pretty
then
important.
you're saying the apps themselves will live on CDN?
So
Because there are a bunch of issues with that. One is privacy. You can't just let people download off of CDNs. Plus these, I mean, generally, these large files. Yeah.
yeah, right. That's a good point. So, and then also, this is data that's changing, all the time. Typically in
Right.
my experience, like you'd use a CDN for like static files and
Right.
stuff that doesn't change too much. So yeah, I was just thinking of that just for like
For
performance reasons,
efficiency.
but it might not be.
Yeah.
Yeah. Okay. So I guess in that case, we would just have the client, like I said, talk to our download service and have it take that um, and have it query S3 directly and send that binary back to the client. But first, it would need to get um, the object ID from our user service,
Mm-hmm.
right?
Mm-hmm. What might be a way to optimize these downloads? Let's say one of the apps become very popular, right? And then many
Mhm.
people are downloading that app. How would you make that more efficient? Because that's really the only case where you need to make it more efficient. Because if only one person is downloading that app, it doesn't matter much if they take slightly longer to download it.
Mhm. Okay. So assuming we have a download service that's really like a cluster of like nodes where we could distribute our traffic. And let's say we have a really popular app. We have many nodes, um, asking S3 for that binary. How do we optimize that process?
Yeah.
My first, I guess, instinct would be, using some sort of caching, but it seems like that would be pretty difficult with like a larger, like we need a
Because
really
it's a
big
large
cache.
object, you think?
Yeah,
Because it's a large object. Yeah.
yeah. I mean, and not just that app, but several apps. Like we would need a really big cache.
Yeah. I
I
mean,
don't know if
that's what my solution would be as well. Because I don't think there is any other solution. But yeah, I mean that's what people do even for YouTube, where where the videos are so large, right? 4K and
oh
all of
really?
that. Yeah.
Oh wow. Yeah. Okay.
So yeah,
And
so
I mean
cache would be a bit, yeah.
yeah, that's probably a whole like design problem in and of itself. So
Yes, for
um
sure. Yeah.
yeah. Yeah. Um yeah, I mean that's what I would do if we want to invest, the time and effort into that, which, at this scale it seems like we absolutely do, then that would be my go-to
Yeah.
strategy. And obviously, let's say assuming we have this set up, obviously we reduce latency a good bit by saving ourselves a call to S3, and we can send that,
Makes sense.
directly to back to our clients for the
Yeah.
download. So I think that covered like the download process. Is there anything else we sort of had to think about in regards to that, or should we move on to payments?
Yeah, let's move on to payments.
Okay. Um, yeah, so we have the ability of users of the application to pay for things. Let's see, apps can be free or paid and have in-app purchases. Okay, so yeah, payments. So when it says apps can be free or paid, let's say an app is paid. Does that mean they actually have to make the payment before downloading it?
Sorry, can you repeat that?
So if an app is paid, it says apps
Mhm.
can be free or paid. So if it's paid,
Mhm.
does that
Mhm.
mean the client actually has to make a payment to our system before downloading it?
That's right. Yes.
I see. Okay. Okay. So in that case, when a client queries for an application and that data that we send back, we would essentially just have, I would think, like a flag of, like free or paid. And so if it's paid, what we're going to need to do before kicking off this download process is have the client talk to our payment service. So that itself would be a microservice. Let's put that up here. And I think of it, like, you go on any like website and, you have to pay, usually a little window pops up and, maybe you authenticate through some third party payment provider. And then once that actually completes, you just continue in, your workflow of what you were doing.
Mhm.
So that's what I imagine like the user experience would look like.
Mhm.
And so when that's the case, we have to complete that process first. And so the client would send a request to our payments microservice. So I was saying that I would imagine the client would send a request to our payment microservice with the application ID, the user ID, and maybe like some payment metadata, like the amount. And I was just saying that I don't know too much about like the internals of payment providers, but
Sure.
assuming, they can give us some, like APIs that we can integrate into our system.
Yeah. Yeah.
We basically just pass that along to them. They handle the
Yeah.
authentication for us, assuming we can build that in.
Makes sense.
Maybe
Yeah.
maybe they give us back like some token that says it's paid. And then once we have that like okay from the payment provider, then
Mhm.
we can go ahead and that call would finish. Then we can go ahead and give them the, say, like link to the download
Yeah.
that we talked about.
Yeah. Makes sense.
Does that make sense?
Yeah, makes sense. I think this is a good place to stop our interview.
Thank you for watching, and don't forget to visit systemdesign.us for more questions and solutions. Please subscribe to our YouTube channel and click that bell icon so that you do not miss any new updates.